Something about Michio Kaku's expression didn't sit right. This wasn't the confident, ever-curious theoretical physicist we were used to seeing on television screens, casually unraveling the mysteries of the cosmos. No. This time he hesitated. His voice cracked. His gaze lingered too long on a single image behind him. And when he finally spoke, the room full of elite scientists, journalists, and space historians froze in absolute silence. The presentation was supposed to explore new data from lunar observation satellites, but what unfolded sent shock waves through the scientific community and beyond. This wasn't just data, it was a new perspective. Something revealed by the moon's surface had just challenged what we thought we knew. And by the end of this video, you too will understand why Michio Kaku was visibly moved, because what they found on the moon raised profound questions. The moon is under scrutiny. Kaku began with a revelation that expanded on decades of research. Utilizing advanced imaging from NASA's Lunar Reconnaissance Orbiter, LRO, researchers mapped the moon's subsurface with technology like the Lunar Orbiter Laser Altimeter, LOLA, and Diviner instrument, more precise than earlier attempts. Instead of uniform rock, they found complex geological features, including volcanic deposits and possible water ice in shadowed craters, some spanning hundreds of kilometers, arranged in patterns that spark curiosity. These features weren't just random formations or simple lava tubes. They showed structure, regularity, alignment. They suggested geological complexity, and when thermal readings from Diviner revealed temperature variations in these regions, readings too distinct to be purely random, the entire room felt the weight of new questions. Something on the moon was more intricate than expected. Whether volcanic, tectonic, or otherwise, Kaku didn't say. He didn't have to. The data invited speculation. Then came the patterns. Gravitational anomalies, once dismissed as measurement quirks or minor inconsistencies, but mapped in high definition by the GRAIL mission, formed a global grid, crisscrossing from pole to pole, aligning with subsurface features and volcanic regions uncovered by radar. This was not randomness. It was geological history. Kaku displayed gravitational maps from NASA and other agencies showing this lunar structure, a complex framework shaping the moon's composition with intriguing precision. If this grid was a remnant of past processes, if it still influenced the moon's stability, then it might affect Earth, its tides, its geological record, perhaps more. The moon, as Kaku hinted, may not be just a satellite, but a key to Earth's history. And if it holds such secrets, we must ask how they formed and what they mean. As he moved from science to mythology, Kaku's voice took on a more solemn tone. He showed depictions from Sumerian, Mayan, and Egyptian texts, all cultures that reference the moon not as an ever-present object, but as a symbol, a guide, even a deity. He quoted stories of nights under its light and sky gods tied to it. Until now, we had seen these as poetic metaphor. But layered over modern lunar data, the old myths began to feel like cultural echoes, like human attempts to interpret the cosmos. Even lunar eclipses, explained as astronomical alignments, took on new meaning. The moon's size and distance are so precise that it can perfectly block the sun, during an eclipse, a phenomenon unique to Earth. Coincidence or cosmic rarity? The more Kaku revealed, the clearer it became. The moon might not just influence Earth's geology, it might have shaped human imagination for millennia. The final act was the most intriguing. Using subsurface radar and high-resolution imaging from LRO, scientists identified reflective materials beneath the moon's crust, minerals like iron and titanium oxides scattered in patterns that reflected radar waves in distinct ways. These were not simple ores. They were part of the moon's volcanic and impact history. When subjected to simulated stress tests and models, these materials showed properties consistent with lunar regolith, meant to endure time, pressure, and impacts. Kaku suggested, without fully claiming, that we might be looking at remnants of ancient geological processes, or perhaps a record of cosmic events. Moonquakes, those seismic echoes recorded since the Apollo missions, began to sound less like random shifts and more like responses, vibrations from deep structures. The moon wasn't just mysterious anymore. It was a geological puzzle, and that meant one thing. Its history was still speaking to us. One of the most haunting revelations Michio Kaku brought to light wasn't new at all. It had been documented for over 50 years. During the Apollo 12 mission, NASA engineers deliberately crashed the ascent stage of the lunar module into the moon's surface to measure seismic activity. What they recorded was striking. The moon vibrated for nearly an hour. But now, with new understanding from GRAIL and AI-powered models, that data has resurfaced as a clue to the moon's interior. Natural rock can resonate, but the moon's response suggested a less dense structure. Kaku referenced simulations from 2023 confirming plausible explanations. The moon's crust and mantle differ from Earth's, possibly due to its formation history. What makes this even more intriguing is that similar impact events later produced consistent vibrations across Apollo missions. The moon was reacting like a complex system. And now we have to ask, what processes shaped this response? And what does it tell us about its origin? Kaku then turned his attention to a mystery noted in recent studies: the moon's faint emissions. Radio astronomers have detected low-frequency signals from the moon's surface, possibly linked to solar-wind interactions or regolith properties. These signals are localized, occurring at specific sites, as if tied to geological features. When filtered through advanced algorithms, some emissions showed patterns, though not resembling artificial signals. Could they be natural phenomena, a remnant of solar interactions? Kaku stopped short of confirming speculation. But the fact that these signals vary with orbital positions is no longer seen as mere chance. Whatever lies beneath that dusty surface might not just be rock. It might hold clues to the moon's past, perhaps even its formation. One of the most mathematically striking aspects of the moon is its orbit. It's remarkably stable. The moon's size and distance allow it to perfectly cover the sun during total eclipses, a phenomenon rare in our solar system. But that's just the beginning. Kaku revealed orbital simulations showing that the moon's path resists long-term gravitational drift, unlike many other moons. Most moons in the solar system exhibit some wobble, some irregularities over millennia. Ours does not. Even more curiously, the moon's rotational speed is perfectly synchronized with Earth, so we only ever see one side. This tidal locking is explained as a result of gravitational forces, but the precision of it, creating a consistent eclipse alignment, is statistically rare. It's as if the moon was shaped to balance Earth's system, and Michio Kaku, usually the optimist, could no longer call that arrangement ordinary. Perhaps the most unsettling part of Kaku's presentation didn't involve new data. It involved what's been lost. He referenced original Apollo mission recordings, including telemetry data and voice transmissions from astronauts, some of which are missing or were overwritten. Reports exist of astronauts noting unusual lights or sounds, though many are anecdotal and unverified. Some claim communications were disrupted on the far side of the moon, but NASA attributes this to expected signal loss. Former NASA personnel have spoken of redacted reports, though evidence is scarce. Kaku, cautious with such claims, noted that gaps in the record raise questions. If the moon holds unique features, as LRO suggests, then those who studied it up close may have seen more than we know. And that mystery might be as compelling as the data itself. As Michio Kaku stepped away from the podium, a silence heavier than gravity filled the room. This wasn't the silence of scientific awe. It was the silence that follows a deep realization that something we've gazed at our entire lives might hold untold stories. The moon, once a symbol of serenity and light, now casts a shadow of mystery. It may not be a simple satellite. It may hold secrets of its formation, and it may challenge our understanding. From its stable orbit to its seismic echoes, from ancient myths to missing Apollo tapes, our knowledge is evolving. And if Michio Kaku, a man grounded in logic and quantum law, is moved by what the moon might reveal, then we should all be paying attention. Because this isn't just about astronomy anymore. It's about what shaped the moon and why it matters to us. Now, the question remains, what happens next? If we truly unlock the moon's secrets, if we explore too deep, will we uncover something we were meant to find? Let me know in the comments. What do you think the moon's data reveals? Is it just a natural wonder or something more? And if this exploration inspired you, don't forget to like, subscribe, and turn on notifications. Because what we'll share in our next video might deepen your view of the sky above us. Because sometimes the truth isn't out there. It's been right above us all along.